So today in this revision class, we will be basically going through the important topics in geography, like the basic concepts that you have already studied, the basic facts that you have already studied. We will be just brushing it again. And I guess this week you are having geography examination, right? So you must be on that geography track. So we will be just quickly going through the topics and make sure that you are able to follow, like you have studied those topics that you have discussed in the class, and also you have studied the points that you are discussing in the class. And also, if you are not like understanding the concept that are taking in the class, you should think that you have to study that topic again. That's it. So we'll just quickly go through the topics. We'll be skimming through the topics. So we know that we have a long syllabus when we have only limited time, so we'll be quickly going. We'll straight away start. We'll start with the geomorphology. In geomorphology, in the starting itself, we need to start with the interior of Earth. That was the first topic that we studied, isn't it? Interior of Earth. Regarding the interior of Earth, we have divided the Earth into 3 layers. What are the 3 layers? Crust, mantle, core. The crust, mantle, core, we are again dividing it into. We have upper crust, lower crust, upper mantle, lower mantle, outer core, inner core. The crust region is also known as. No, crust region is not lithosphere. The crust region is also known as. What is lithosphere? Yeah, in the region of upper mantle, we have a semi-solid layer, and what do we call that semi-solid layer? Asthenosphere. So the region above asthenosphere, this is lithosphere, which includes the entire crust plus some portion of upper mantle. The region below the asthenosphere, which contains the remaining part of mantle, it is known as the mesosphere, and the core region, bathysphere. And regarding crust, we know that crust is in solid state, asthenosphere is in semi-solid or plastic state, mantle, remaining part of mantle, solid, outer core, liquid, inner core, solid. The reason for inner core being solid is that even though the temperature is high, the pressure is also high, and also the elements which are contained in the inner core are nickel, iron, etc. So they are having such properties. And also, when we are moving too deep into the Earth's interior, we know that Earth is not homogeneous. It is not having a continuous nature. We are having several discontinuities. The discontinuity between the upper crust and lower crust is known as Conrad discontinuity. Discontinuity between the lower crust and upper mantle, Mohorovic or Moho discontinuity. Upper mantle and lower mantle, Repethy discontinuity. Then mantle and core, Gutenberg discontinuity. And outer core, inner core, Lehman discontinuity. Okay, and we know that Earth's radius is around 6,400 kilometers, and out of the 6,400 kilometers, the thickness of the crust is around 8 to 40 kilometers, mantle is around 2,900 kilometers, and remaining part is the core. And majority of the mass and the volume of the Earth is occupied in mantle. When we are moving deep into the Earth, from the surface of Earth, we know that the temperature increases, pressure increases, density increases. Density at the core is almost 3 times the density at the crust. Okay. And how do we get information regarding Earth's interior? What are the sources? We can divide the sources into 2: direct sources and indirect sources. Give me some direct sources. Volcanic outputs, then mining, the rocks from the mining areas. Give me some indirect sources. Seismic waves, meteors, change in temperature and pressure when we move deep into the Earth, like the mines area, etc. Then gravity. So these are the indirect sources. And within geomorphology, we also need to study regarding some theories. We started with the continental drift theory. Continental drift theory was who proposed it? Alfred Wegener, who was a German meteorologist. And according to Wegener, all the 7 continents that we have today were together in the past around 250 million years ago, and it was called as Pangea. We had only single supercontinent, Pangea. So we had only single super ocean, and that is known as Panthalassa. And Wegener says Pangea started to split. It split into 2. The northern part or northern half is known as the Laurasia or Angara land. Southern part is called as the Gondwana land. The water body separating Angara land and Gondwana land, Tethys Sea. Okay. And according to Wagner, the drift was in two directions. One was towards equator, other was towards west. What was the cause or what are the forces that resulting in the drift? Tidal force is there, buoyancy is there, gravity is there, Earth's rotation. Okay. And what are the evidences that was put forward by Wagner? He took the examples of the shape of the coastal areas. Okay. He took the shape of the coastal areas of the eastern South America and western Africa, and he took the example of the alignment of the very old fold mountains. He gave the example of fossils. He also gave the evidence of using the placer deposits, rocks, etc. And it was having a lot of drawbacks. What were the major drawbacks? These forces were never enough to cause the movement of the earth. Then they were general in nature, very much into assumptions. Then anything else? Wagner failed to explain why the drift started 250 million years ago, or before that, what was the force holding them together? Why the drift didn't start before that? He failed to explain all those. So when the new theories came, they accepted the concept of Pangea, but they rejected the mechanism behind the drift. So we have the modern theories like plate tectonic theory. According to plate tectonic theory, the earth is divided into, or the earth's lithosphere can be divided into 7 major plates and several minor plates. Okay, earth's lithosphere can be divided into 7 major plates and several minor plates, and these plates are freely floating over asthenosphere. These plates are freely floating over asthenosphere, and within the asthenosphere, when we have change in temperature and pressure, there will be some movement, and we call them as convectional currents. So according to plate tectonic theory, these convectional currents are the reason for the movement of the plate, and the theory states that these plates move and they interact with each other. We studied 3 types of interactions: convergence, divergence, and transform. Convergence means when 2 plates are coming towards each other. What happens there? It's basically a destructive boundary because one plate subsides below the other. So it's a destructive boundary. Convergence means destructive boundary. Divergence means constructive boundary. A new landmass is being created. What about transform boundary? Neither destruction nor construction. The land area is getting conserved. So we call it as the conservative edge. It is also called as the conservative edge. And the crust, we can divide it into continental crust and oceanic crust. What are the differences between continental crust and oceanic crust? Continental crust is less denser, oceanic crust is denser. Continental crust is thicker or thinner? Thicker. Oceanic crust is thinner. Continental crust is made up of rock called as granite. Oceanic crust is made up of rock called as basalt. So we are applying this convergence and divergence on the continental plate and oceanic plate. What happens when 2 continental plates converge? We have fold mountains. Fold mountains. We have compressive force being generated over there, and as a result, we have folding and we have the formation of fold mountains along a continent-continent convergence. What happens during a continent-continent divergence? Continent-continent divergence. We will be having volcanic activities, and we also have the formation of block mountains. We call that process as faulting. Block mountains. We have 2 block mountains and valley in between. We call them as what valley? Rift Valley. They are called as Rift Valley. We have the East African Rift Valley as an example. What happens when one continental plate and one oceanic plate converge? Trenches will be formed. Mountains will be also formed. What happens when 2 oceanic plate converge? We have islands or sea mounts being formed. What happens when 2 oceanic plates diverge? Ridges, mid-oceanic ridges. These are all facts. Like if you are not getting it clearly, you just make a small note. CC, continent-continent convergence. This is fold mountains. Continent-continent divergence, block mountains, ocean-ocean convergence. So you make a small note of it, and so that you can revise it again and again. Okay. And if you start with the mountain building, we usually say that fold mountains are there, block mountains are there. We also have another type called as the residual mountains. We also have volcanic mountains. Fold mountains, continent-continent convergence. We usually have the fold mountains like this. This portion is called as the What do we call that? Anticline or syncline? This is the syncline. What are the different types of fold mountains? Symmetric fold, asymmetric fold, isoclinal fold, overturned fold, recumbent fold. What is symmetric fold? What understand by symmetric fold? Suppose this is the mountain, this is the axis. If the axis is vertical and if both the sides or both the limbs are symmetric to each other, we call it as symmetric mountains. If the axis is a bit inclined and we know that one side is steeper, other side is gentler, asymmetric. If both the limbs are almost parallel to each other and parallel to the axis, we call it as isoclinal fold. Symmetric, asymmetric, isoclinal. If the axis is inclined at more angle, we call it as overturned. If the axis is almost parallel to the ground, we call them as recumbent. This is the difference. Okay. If both sides are almost symmetrical to each other, we call it a symmetric fold. One side is steeper, other side is gentle slope, and the axis is a bit inclined means asymmetric. Both the axes are both the limbs are parallel to each other and almost parallel to the axis means isoclinal. Then we have it turned at an angle called as overturned fold, and if it is almost parallel to the or it is almost horizontal, we call it as recumbent fold. These are the types of fold mountains. Similarly, we have block mountains. Block mountains, they result in the formation of rift valleys. Okay. Normally, we represent the block mountains like this. So, this region is called as the rift valley. This is the block mountain, and it is also known as the horst graben topography, where this mountain part is called as the horst and the valley part is called as the graben. Okay, talking about earthquake, we know that earthquake is the sudden release of energy from the earth's interior. Most of the natural earthquake occurs within the lithosphere only. It starts from the lithosphere only, and energy is released in the form of seismic waves. The point within the earth's interior from where the energy is released is known as hypocenter, seismic focus or focus. The point on the earth's surface which is very much whatever. Yeah. Okay. The point at the surface of earth which is very close to the focus, it is known as epicenter. And seismic waves, we can divide the seismic waves into two. Body waves and surface waves. Body waves can be again classified into primary or P waves, secondary or S waves. Surface waves can be again classified into love waves and Rayleigh waves. P waves or primary waves, they are the fastest among the waves. They are longitudinal waves. They can travel through solid, liquid and gaseous medium, isn't it? S waves, they are slower than P waves. Then they are transverse waves. They can move only through solid medium. Longitudinal transverse means in longitudinal, the vibration will be in the same direction of the wave propagation. Transverse means perpendicular. Moving to the surface waves, when this body waves, as the name indicates, they travel through the interior of Earth only. When it comes to the surface, they become surface waves. And surface waves are completely transverse waves. Okay. Among body waves, P waves is longitudinal, S waves is transverse, surface wave is completely transverse. What is the difference between love waves and Rayleigh waves? Which one is horizontal? Love waves? Horizontal. Rayleigh waves is vertical. That is the basic difference between love waves and Rayleigh waves.